Okay, we are live again.
All right.
I have our ultimate presenter here. I have Trevor DeVore.
Hello.
So I'm just seeing, yep, people are joining. We've got 72 people. So they've definitely found us again. And just telling some people that we are live. They haven't quite joined us yet.
Let's see. So I have the chat room and the videos. Okay.
So.
All right. Well, you just let me know when to start, Heather, and I'm.
Yeah, sure thing. Okay. Well, I'll just give them a moment or two. Let me see if we have a. We should have the invite. Should have arrived by now. Certainly got mine. Okay, let's just kick off, and I'm sure everybody will manage to trickle in.
All right, sounds good. Okay.
So Trevor is going to talk to us about Levure and his exciting app framework. And he is, as we know, the co-founder of the highly successful Screen Steps, which we use to power our lessons. And it is a very excellent piece of software. So keep it up. Over to you.
We won't
Take it away.
All right. I hope everyone's doing well today. It's I've been in and out in some of the presentations today, and it's there's been some great content. It's been neat. I always like watching Scott. Every time I walk away from one of Scott Rossi's presentations, I have to go back to my app and implement some new eye candy, because I love what he displays, the stuff that he shows. So we're going to get started here. I'm going to show my slides, and we are going. For those who aren't aware of kind of what I do, I've been working in LiveCode for I think since about 2003 or so. It's been a while, not as long as a lot of people, but longer than some. And ever since I came to the platform, I remember the first time I came into the platform and I made my first application. I always struggled with, how do I organize files? I mean, we've got, LiveCode has all these stacks and things like that we can use to create our apps. And I've always struggled with how to organize an application. And it's something I struggled with on my first app, and it's something which I had solved to some degree over the years. And about last November or so, I decided to need to take a fresh look at it because I had some new requirements. So I'm going to be talking about what I've come up with, and it hasn't just been an effort, my own effort. I've gotten a lot of input from various people, and I think when I first started doing Levure, I was chatting with Monty Golding, and I remember he just asked me a question. He's like, "What if it did this?" And from that question, like, it spawned this whole change in how I was looking at how to solve the problems, and so from there I kind of took it and have what you see today. Also, I want to say a big thank you to Brian Spencer, Spencer Learning. He has a couple months ago, he hopped on board, and he has been writing a huge amount of documentation for Levure that you'll find on the wiki. So if you are, Heather, I think they have access to the folder on the resource folder. I put a couple different files in there. There's a Levure README that has links to the GitHub account, the wiki, licensing information. It's an MIT license. Just any questions you might have are in there, as well as the slides.
Yeah, I haven't quite shared that link yet with everybody, but I will most certainly be sending it out probably tomorrow if people can wait until then.
Oh, okay. Well, then I'll just make sure I'll show it to. Let me do that really quick then. Let's put that in. Let's put that in the chat window. So,
yeah.
Luckily, that'll come up. Let's see. So GitHub. Okay, so in the chat window, that's the link to Levure, and you will find the wiki at the link below. I pasted the link to the wiki as well. And Brian has been incredibly helpful with going through and writing that documentation. And projects don't get off the ground if you don't have a team working on it, and especially somebody who likes to write. So thanks for that. And we've Mike has also done a ton of testing early on. He adopted early on. He asked lots of great questions, helps me see the holes in coding that I've done and problems that I hadn't thought of. And so big thanks to him as well. So let's get into this now and talk about Levure. So what is Levure? If you're wondering what the name is, where it came from, it is the French word for yeast. I don't know, all great breads start with yeast in my opinion. I like to bake breads. How does that relate to apps? I don't know that it does, but I really liked the name. And it's one of those things where you're thinking, oh, what do I name this? And Levure came to mind, yeast, great bread, apps, right? Makes a lot of sense. So Levure is, let's look at this next slide. Levure is a way to expand our tool set. As LiveCode developers, how do we bring in other tools that have become industry standards that other people, other groups, other organizations are using to write great software? So at my company, we have a combination web application and desktop applications. So we have a couple of desktop applications that we write in LiveCode. And we also have a web component that's written in some other languages. It's a combination of Ember and Ruby on Rails. And for those other programming languages, we have teams, and we've had lots and lots of programmers that have worked on and contributed to those code bases, and they've all been working at the same time. And we've been able to use these tools, such as version control software. We use GitHub to manage our source code. And I was looking at that and thinking, there's so many benefits to this. And how do I get access to that in LiveCode? How do we draw on these great tools that are out there so that we can have teams of people working on great apps in LiveCode? How can we get our stuff into these into these source these version control systems? So as I looked at the issues that are involved, the current issues with LiveCode, what kind of kept me from using the tools I wanted to use? Well, the first is LiveCode. The format is binary, right? We have our user interface and our code that are inseparably connected. They are all in one file. You could have 100 stacks sitting in one file, one stack file, and you open that up and it looks like a single file on disk, but you open it up and it's this whole world of user interface and code and wonderful things. But that is not, version control doesn't like that single binary file. You can't see the small changes that are being made. The other next issue is you have to rely on tools that run within LiveCode, the LiveCode IDE, or that are being run by the engine, to browse your stacks and code. Because LiveCode is this binary format that other applications don't understand, all of our tools have to be written in the LiveCode IDE. And while it's not a bad thing, there's a lot of great tools out there, but it is a negative in that we can't draw upon these other tools that that people have been creating that are really powerful. And the last issue that I saw was that we have no standard way to organize our stacks into an application. This is a problem that's in my mind has always been present in LiveCode. Lots of us who have been around for a while have come up with our own ways of doing that. I had the GLX app framework that I used for years that worked for me, a couple other people, and I used that up until the end of last year, and I still have some apps that use it today. But there was no standard, and so as we look at hiring other LiveCode programmers to work on our projects, there's always a learning curve. They're always going to have to figure out first, all right, how does all this fit together? And I years ago, I've come in on projects, and they're like, okay, well, you can't help me with this. And first you have to figure out, okay, well, how does this all fit together? Like, what's going on here? So I saw that as an issue as well. So the solutions that I saw as I thought of this problem was, what if we move the application organization into the file system? If we move it into if we move all the organization into the file system, we instantly have access to a host of other tools, right? First of all, we can browse our, the high-level application structure using your file system browser. Any text editor that, most text editors these days, like the professional text editors, are going to allow you to open a folder or have a project of folders where you can browse the hierarchy of a project. And so just by moving organization into the file system, we open up a whole world of tools that can help us with our app. Well, the next solution is, okay, what if we can move our scripts into text files? All right. Now, one of the big changes that happened to the LiveCode engine was that this concept of script-only stacks came about, and the LiveCode team implemented script-only stacks. And we'll talk a little bit more about what those are in just a bit. But that allowed us to move code into a text file, and text files play really well with version control systems. And so now all the logic and once an app's established, the majority of changes are happening in your code base. By moving those scripts into these text files, then they'll play well, one, with version control systems, but you can also start browsing your scripts in other text editors. Maybe you have a text editor of choice. There are some really powerful text editors. There are entire companies dedicated to creating text editors. And if our scripts are in text files, we can use those. We can benefit from those. Even if you're not even editing that code, you may find that the search features in some of these editors are something you really need, but it opens up, again, it expands our tool set. And lastly, if we look at the problem of how do we organize all of our assets, all of these stacks, everything that our app is made up of, how do we bring those together in a way that we can define what the application is? Well, let's move the definition for an app, let's move that into an easy to read plain text file. Again, that plays well with version control. There are, you'll see, I chose YAML as the format to use for that, for the configuration files. And I think it's a wonderful way to, I don't have to open up a stack, open up the custom property inspector, or open up some, custom plugin that I made. I just open up the text file, read it, can see exactly where the assets are. It works well. So, kind of recap, what are we getting here with the way Levure lays things out, how it organizes your applications? Well, by using the file system, you can browse your application structure using a file browser. By moving code into text files, you can look at scripts using your text editor of choice. By standardizing the system, you reduce the learning curve for new developers, and using the file system and text files allows for the use of version control systems. Now, I'm going to talk a little bit. I'm not going to go into a ton of detail about version control systems in this presentation. This is an introduction. And Levure, you don't have to use version control systems to find value in Levure. It's a benefit, and it might be your end goal, but it doesn't have to be something that you start using right away. You can get a lot of value out of Levure before that. But I will just mention a couple of points on version control systems. A version control system can do the following. It can provide a detailed history of code changes. Now, right now, I'm currently, I migrated our largest product over to Levure over the last 6 months. And even as I've been the only one working on it as I've gone through that process. But having this detailed change log, and I can show you some examples, of what like a change log looks like later on if we have time. Looking at this detailed change log allows me to see exactly what was done, and I can go back and I can revisit things that I thought I fixed, but I really, I broke something else. I can go back and see exactly where that change was introduced, and it gives me a lot of power for kind of seeing how my app changed over time. It reduces errors. Now, what happens is when you're using version control is you write the code that you're going to, that it fixes a bug or adds a feature, and you finish that up, and then you have to go into your version control system and you have to commit those changes. You have to submit those changes to the repository. And when you do that, you're looking at it through a different set of eyes. And I'll often find that I find errors, or I find things that I didn't. I'll look at it and say, oh, I forgot about this case, and I'll go back and fix it. And so it gives you that second chance to look over the code and catch errors. Now, when you're working with a team, you'll actually have, in our other software projects that my company does, we always have a reviewer. So one programmer programs, writes the code, fixes the bug, submits it, and then another programmer reviews it. And that way we can say, hey, well, maybe there's a better way to solve this problem, or everything looks good, okay, let's commit it. Third, it allows you to work on, a version control system allows you to work on multiple features at the same time in isolation. An example of what I'm talking about is I recently implemented TSNet into my ScreenSteps application. And that was something that it touched a lot of points in my app, and I needed to do a lot of testing to make sure it was working how I wanted it to work. Now, while I was trying to implement TSNet, I still had to maintain my software. There are still other, TSNet was probably implemented, I don't know, over a few months. And well, I tested it out and did different things. But I was still fixing bugs in the software, releasing updates to customers, adding a feature or two here or there. And I needed to be able to do both at the same time. Well, in version control software, you can have these branches and you can work on these changes in isolation. I can have a TSNet branch that I work on, and I can have bug fix 1, bug fix 2 going on in the other branches. And then when the TSNet's ready to bring in, the TSNet changes are ready, I just bring them in and it's great. And then lastly, version control facilitates team development. So these are things to think about as you're looking at whether or not you want to move into version control right away. If you're working on a team, to me it's an obvious move, but even as an individual, there's some value there. Before we get into some actual examples of working with Levure, I want to make sure that everyone here understands 3 important concepts. You're going to need to understand these things for the presentation: script-only stacks, behaviors, and YAML. And the reason is, if you don't understand what these 3 things are, then everything else becomes rather confusing. So first, script-only stacks. This is a relatively new addition to the engine. I don't know when it showed up exactly, but maybe in the late 6 series or something like that. I'm not sure, but there's been some changes to it that make it a great tool to work with now. What it is it's a text file, and script-only stacks are text files. And the first line of the file is what specifies the name of the stack in memory. So if you look at the screenshot, it's script Levure framework. So if I was to open this levure.livecode script file in the LiveCode IDE, then it would create a stack called Levure framework. And the rest of the file, after the name of the stack on line 1, it's just LiveCode script. That's all it is. And so it's not very complicated. And what happens when you open by the LiveCode engine, so in the diagram on the right, you see that the Levure.livecode script, that's a script-only stack. LiveCode script is the extension that is what kind of the emerging standard for script-only stacks. When you open that, it looks like any other stack in the project browser. And if you were to double-click on that stack in the project browser, it would open up a window, and you would see that stack appear. Now, if you add any controls to that stack or do anything else and save it, it all disappears. No visual representation. There's no properties that are stored with it. Remember, it's just a text file with the name of the stack and a script. But you can add controls to it while it's open, and you can have a script that dynamically generates a user interface, and then it all disappears when you save the stack and close it down. But really, script-only stacks are appropriate for. It's a great format for libraries, front scripts, back scripts, and behaviors. Those are very often those are things in LiveCode that are just scripts anyways. Sometimes you might have to use some other assets for your libraries, but oftentimes they're just scripts, and so it makes a lot of sense to use script-only stacks for them. Now, behaviors. So this is a very high-level description of behaviors. I just want you to understand this as we get in. Behaviors allow you to use code from one control within the context of another control. So the behavior property of control A, so look at this button on the right, you say a button, that's control A. It points to the script of another control, which in this case would be the script in the code.livecode script behavior. So the script in the code.livecode script file is kind of brought in, and it becomes the script of control B acts as if it's the script of control A. Now, there's some subtle differences. It's not like they're exactly the same, but I'm not going to go into those here. But just think of it as the script of control B acts as if it's the script of control A. And so that allows us to bring this external code into a user interface and have it be like it's assigned to the button. But the benefit is the script is stored outside of the binary stack in that script-only stack. And so it means it's plain text. So moving on to YAML. That's our little quick intro to behaviors. And lastly is YAML. YAML is from the YAML.org website. It's a human-friendly data serialization standard for all programming languages. YAML is something I use in the other programming tools that I work in, the other environments that I work in. I really like it. I think it's simple, easy to read, easy to write, and it uses indentation to create the hierarchy. And it becomes a multi-dimensional array when it's imported into LiveCode. Monty Goulding provided the current parser for that, and And that was wonderful when he sent that to me. We kind of had a hot pot. We had a barely working YAML parser for a while, and Monty gave us a really good one recently. So there we go. There's our background on Levure, the philosophy behind it, some concepts that you need to understand as we look at some examples of using it here. And now let's dive in and actually do something. I'm going to exit out of the slides. And we're going to load a video. Okay, so I'm going to load this video, which is something I pre-recorded, and it will go through. This is going to go through creating. Let's change our slide there. It's going to go through creating a Levure application.
Creating a new Levure-based application is really straightforward. On the GitHub site, you'll find the Wiki tab, which has a Getting Started section and a Creating an Application page. And on that page, there is some LiveCode script that you can copy and paste into LiveCode. So I've just selected that LiveCode script, I've copied it. I'm going to switch over to LiveCode and open the message box, paste that URL, I'll press return, and that will load a stack from the GitHub repository. Then this stack is called Create Levure Application. This stack has all the code necessary to create a new application on your computer. It will download the Levure folder for you. It'll set up all the folders and set up a little sample window that will open up when you launch the app, just to make sure everything's working. I'm going to switch to the Browse tool. I'm not going to worry about any of the Git options. That's not important right now. And I will click Create Levure Application. Now you're going to want to create the application inside of a dedicated folder. So I'm going to create a folder called My Great App, and I will then select that folder, and I'll just wait until I see a message that says that the app's been created. So once that's done, you can go ahead and close this stack. Let's minimize this. Now I can open up the application that was just created using File menu. So I'll select File, Open Stack, and you'll see that there are 3 different folders that were created. When a Levure-based application is created, you'll see an app folder, a builds folder, and a Levure folder. For now, we're just going to go into the app folder because that's where all of your application files and assets will be stored. And I'm going to open the standalone.livecode stack file. When I open that stack, I'm going to open the inspector, and you'll see that in memory that the standalone.livecode stack file is named Levure standalone. If we look at the stack files for this stack, you'll see that it points to the Levure.livecode script stack file, and in memory that's called Levure framework. And the behavior of this Levure standalone stack is the Levure framework stack. So this Levure standalone stack is what loads the Levure framework into memory, and then when you click on this Open Application button, this button's you only have to click on this when you're running your app in the IDE. But clicking this button will tell Levure to load up all of your application files and kind of get everything going. So I'll click on that, and you'll see a little sample window that appears whenever you create a new application. A sample window is added to the folder, and if you click on the Click Me button, it just shows you that everything is hooked up and working properly.
Okay, so that was showed us. We just looked at how we can, that Levure has a tool that that we can use to create an application. Kind of get the basics of the application in place really quickly. So now let's look at how we bring my slides back. Within the LiveCode, within the Levure application. Okay, so organizing application files. So in the screenshot on the right, what you have is I've highlighted the folders that you saw in that video. We have these are the folders where you can, by default, where you can place files. Now, Levure loads files differently based on where you put them. So for example, if you put any files in the assets folder, those aren't going to be loaded at all. Levure doesn't do anything with those files, but there is an API call. There's a handler that you can use to get get the path of that folder. So maybe that's where fonts that your app uses are stored. Maybe you have a licensing information like a PDF in there. It's kind of where you stick all the different assets that your app might need. Now, if you put a stack or a script-only stack into the back scripts folder, well, when Levure loads that, it's going to issue the command insert script of stack X into back. And so it's automatically loading that as a back script for you. The same would happen, for front scripts, insert the script of stack X into front. Now, the behaviors folder is a little different. So behaviors, it's really important when you're using behaviors that if let's say that I have a stack that's being used as a behavior, that stack has to be loaded into memory before any other stacks that might reference that behavior are loaded into memory. And so what Levure does is if you put any stacks or script-only stacks in the behaviors folder, those stacks are going to be loaded into memory before any others. And make sure that they're in memory, and when any of your user interface stacks load up, or your library stacks or whatever, those behaviors will be available. The next folder in our list is the helpers folder. Now, helpers is a Levure concept, and you think of helpers as drop-in features. And if we have time here, we will talk about that a little more. But the idea is that a helper is a folder, and it's a combination of stacks, images, extensions, externals, whatever you need as a developer to implement a feature goes inside of this folder. And you have you have a YAML file which tells Levure how you should treat each of those files. And so you take that helper folder, you drop it into your Levure helpers folder, and that becomes a feature that's available to your application. So for example, Levure has 7 helpers that come with it that you can use. One of them is preferences. Now, in order to implement preferences, there's an external that runs on OS X, and there's a library stack that handles preferences on the other platforms. And as the developer writing an app, you don't have to worry about loading those files properly. The helper does all of it for you, and you just get to use the feature. Next folder is libraries. Again, just like front scripts and back scripts, it's going to load the stacks in that folder as a library. It's going to say start using stack X. And the last folder, which is the UI folder, which we're going to look at in more detail in just a bit, but that folder, it contains all of your user interface stacks. And those stacks are not loaded into memory when you open a Levure application, but Levure makes all of the stacks available to code. It sets the stack files property of one of the Levure stacks so that you're organizing all your stacks in these folders, but you don't have to know where they're stored. In your code, you can just say go stack my window, and the LiveCode engine will know where to find that for you. So Levure's not adding an extra cognitive load or extra code that you have to worry about when you're loading your UI stacks. Okay, so that's how you organize your application. Let's look at configuring an application. The app.yml file is a YAML file, and that's what brings the application together. So all of your application settings are configured in the app.yml file. And let's take a look at what that looks like. I have 2 examples here, and let's hide the slides. And here we go. So in the demo you saw earlier of creating a Levure app, this is what the app.yml file looks like for a newly created application. You give it a name, you have version information, whether or not you want to encrypt the stacks. You can set an application data folder where your app can store data on the different systems. If you're using preferences, you can specify the file name to use for preferences on each platform. And here, as we get down, you see here on lines 34 through 47, This is where you've configured the app to, you tell it, okay, where's the UI folder? Where are the libraries folder? Where's the front scripts folder? And by default, actually, I'll delete this line. This line isn't part of the default. I was going to show that to you. By default, you see, the UI just references the UI folder that sits alongside the app.yml file. Now, you can pull in content from anywhere. So perhaps you have a shared folder. And that's what I was doing what this previous line was. Maybe elsewhere on your system, you have a shared assets area where you have multiple apps that all use the same UI elements. Well, you can specify, you can add a line to the YAML file and tell Levure where that folder is, and that those files will get loaded up. Also, if, for example, you want to use one of the helpers that comes with Levure, well, you can add a file name entry to the helpers section, and you can tell it where to find that helper. And whenever you're referencing a helper that ships with Levure, you use this little framework variable, and then Levure knows that it needs to go find one of the built-in helpers. So that's for preferences. There are also settings for specifying where your builds should go. So when you package up an application or you're building a test, a standalone for testing, you can tell it where to go. By default, it goes to builds. And then there's places where you can specify certificates for code signing on Mac OS. You can tell it which files should be copied. The assets folder gets copied across by default. You may have other files that you want copied across. So that's what a bare bones one looks like. Now here's a more sophisticated YML file. This is from my Screen Steps application. You can see that a lot of the fields are filled in. So for example, the application data folder, the names of the preference files. You can define URL protocols. There's a helper that allow you to do that. So whenever my app runs on Windows, it makes sure that it has registered itself with the system. So if somebody clicks on a link that's prefixed, if you click on a link in your browser that's prefixed with Screen Steps, then it will send the URL to the desktop application. Here's an example of, from the UI, I encrypt all my stacks, but there are a couple that I don't want to encrypt, because you don't want to encrypt a stack that you're going to copy content from, because the engine doesn't like that. So what Levure allows you to do is you can say, at the beginning of your list of UI elements, you can say, I want to load this specific file, and I don't want you to encrypt it. And then later on, I can load, on the next line, well, then we load all the other UI stacks that are in this shared assets folder. And Levure, because you already set the encryption setting for this specific file, you don't have to worry about, Levure will not override that when you load all the other UI stacks in that list. So you have the point is you have a lot of flexibility in how you configure things. Here you can see my app uses a lot of helpers. I've been moving I have a lot of code that I've moved into helpers. I think it's an easier way to design specific features. So I've been using that system. Font, there's a font helper that comes with Levure. So you just tell Levure, okay, here's where the font's located, and then the helper will make sure that font gets loaded and unloaded and packaged up with your application. You can specify file extensions. So these are all the file extensions that my app supports. And so if a user were to drop a file onto my app and the file had one of these extensions, my app would get a message saying, hey, you need to process these files and do something with them. And then there's also commands for creating filters for answer and ask dialogues and things like that. And then here you see we have a bunch of, these are the build profiles, the copy files. So, I use INO setup for my Windows installer, so those files get copied over, and there's some other resources and things. So that is, that's kind of an introduction to the configuration file. That's what we're looking at. So now I want to spend some time on, I want to show you how to add user interface. So user interface stacks, That's the one area in Levure where things are treated a little differently. For libraries, front scripts, behaviors, you could just drop existing stacks right into those folders, and they're going to get loaded up and they're going to work. You have to organize things for the user interface a little bit differently. So I have a video on that I prepared that we're going to watch now. So this is how to create a UI stack in Levure, and it's going to start with a basic example and then show you how you can move on to script-only stacks and behaviors. Here we go.
Now I'm going to walk you through the process of adding a user interface stack to your application. User interface stacks are going to be anything that you display to the user. That's going to have an interface that the user is going to interact with in order to execute code in your application and perform some sort of task. So like any stack file or asset that's going to go in your app, you're going to put it in the app folder. And there's the UI folder, which we talked about earlier, where you should put all your user interface stacks. Because Levure is going to load these stacks in a special way in the IDE. So what I'm going to do is I'm going to create a folder. All user interface stacks go in a subfolder inside of the UI folder. I'm going to create one called main window, and then I'm going to go into the IDE, and I'm going to create a new stack. I'm just going to give it a name, main window. And I'm going to add a button to it. And it's going to be a friendly button. So it's going to say hello. Okay. So now I've got a very simple stack. I have a button. I click on the button. It says hello. I'm now going to save this stack inside of the app UI main window folder. Okay. And so that's it. I've now added a user interface stack to Levure. It's very simple, but Levure will now load this it'll make this user interface stack available to the application when the app launches. Levure doesn't actually load the stack into memory, but it makes it available so that if you try to open it, if I were to execute go stack main window in my code, Levure would know where to find that stack and would open it. So that's step one, and a Levure application will work just fine if you design a stack like this. Now, if we want to take this a step further and we want to now move this code, the code for the stack, out into behaviors, out into these script-only stacks so that the code is in a text file, well, then we have to do a little more work. Luckily, in LiveCode 8.1.5, this has become a lot easier. If I double-click on this mouse button, I can, if we go to a behaviors tab, right here in the behaviors tab, there's actually a feature now when you click on this little target icon where you can create a behavior from a script-only stack. And I can create that behavior using the existing script of the control, or I could create an empty script. Now, when I'm adding behaviors for these user interface stacks, I usually like to attach the behavior to the card or the stack, and then the actual buttons will call functions within that card. So what I'm going to do here is I'm going to go to the card inspector, and I'm going to create a new script-only stack behavior. I'm going to call this main window card behavior. Now this is going to be the name of this script-only stack in memory. Click OK. And I'm going to save it. Now, see, we're in the app UI main window folder. I'm going to create a behaviors folder. I like to organize behaviors into a folder. I'm going to accept the default name. And what just happened is LiveCode created a script-only stack, and you can see the script is open in the background here. It assigned that stack as the behavior of the card. And it also, if we open the stack inspector, you'll see that it added the script-only stack file name as a stack file of the main window stack. And what that means is when you open this main window stack, LiveCode doesn't know where to find stack main window card behavior. If it hasn't already been opened up by the engine, LiveCode won't know where to find it. So by adding a reference to the stack files property, it tells the engine where to go out and find the my main window card behavior stack. So that was all automated for us. Okay, so let's go back to, we are now in the card, the behavior that is being used as the card script. So I'm going to write a command called UI clicked button, and I'm going to say answer hi there. Ooh, there we are. Okay, and then I'm going to save it, because when you're working with script only stacks, you usually don't have it open, so you're not going to like click on the stack and use the file save, the normal file save button. So when you're editing a script only stack, you'll use the file save menu from the script editor. So that's now been saved. And what I'm going to do is, because this button is always going to be stored in the binary LiveCode file, I'm going to keep a minimal amount of code here. So what I'm going to do is I'm going to call the UI clicked button command from the button, and these 3 lines of code are going to be stored in the binary stack. If I was using a version control system, I wouldn't be able to see exactly what was changed if I ever came back in later and changed this script. Like if I decided that I wanted to make sure that only the left button triggered this command, you know, that change, I wouldn't get the version control system wouldn't show me exactly what changed. But that's not a big deal, because that code's not going to change very often. So now what I've done is nothing, because I spelled a variable incorrectly. There we are. Hi there. So when I click on that button, it says hi there. But what I have on disk now is a binary stack that has the UI elements, but then I have a text file that has all the logic. And I would go and I'd build out my logic within this this text file here, and then the user interface would call into that behavior.
How do we create an application? How do we organize an application? Where do we put our files? We looked at how we would add user interface stacks to our application. You know, so you could take your existing user interface stacks and just drop them into into folders within the UI folder, and you could start converting your app really easily that way. So we've got that down, and kind of to close out this presentation, I want to show you kind of how packaging works with a Levure application. So once you're ready to deploy an application, how would you go about doing that? So I'm just going to show you a basic example here now. A Levure application, there are commands that you can use to test, like in the iOS simulator or in the Android simulator. There's another command that you can use to build a test build. But the command we're going to look at right now is how to, let's get rid of the doc, how to package up a release version of our application. And before we do that, when you open the standalone.livecode stack, which you see right here on the screen, remember from earlier, that's where you configure your standalone settings. So I open up the standalone settings, and for the sake of this presentation, I'm just going to do Windows, Linux, and Mac, and I'm going to close that. The other thing I do is I turn off search for required inclusions, because LiveCode won't find anything because there's nothing in here. So once I've done that, then I can just do Levure package application release, and LiveCode is going to go through and run the standalone builder for all 3 platforms. There's dialogues popping up on the screen, but they're on my other monitor. Fortunate for us, you can't see them, so just know that something's going on another monitor. And now it's done. And so what happened is, in this builds folder, there you'll see a build log, and then you'll see release. So this is one of the build profiles that was, release is a build profile that was configured in the app.yml file. And you see here's the version number, and here are the platforms. So I'm on OS 10. I can double click on that app, and it opens up, and it works, and all is well and right in the world. If I had Windows running, I could test the Windows or Linux for Linux versions, you kind of see how the files are organized. When Levure packages up an application, for example, it would take all the behaviors and put them in a single file. It doesn't use the same, the UI format will be similar, but it will combine all the libraries, it will combine all the behaviors, all those other files, it will combine them into a single file that gets loaded more quickly when you're running as a standalone. And there's some other things that go on. But that's really all there is. It's a single command within Levure, and it will package all that stuff up, just reads the app YAML file, gets all that information, and get your app ready to release. So on Mac OS, if I'd had if I wanted to code sign that, and I could enter my certificate name, and that would get code signed. For Windows, I have here. I'll switch over to Screen Steps and show you some example builds over here. So if we look at release, so I get, I have a script that gets run during the build process that creates the DMG file. I also generate these Windows installer files. The ISS is for INO setup, and so I open those up in Windows, and it takes care of building the Windows installer and code signing everything that needs to be code signed. And so it's really a quick process when it comes time to package things up, because the majority of things I haven't been able to automate the Windows installer and code signing because I build on Mac. So there's going to be one of those that has to be done manually. But overall, the whole process is very quick. So that is it for the main presentation. I know we started about 10 minutes late. I'm happy to start taking questions now, so that we can end a little closer to the right hour. I can also go into a little more detail on helpers if people are interested in that as well. But yeah, so we can. Hi, Heather.
Hi. I'm just saying there's a couple of questions coming into the chat if you want to perhaps go over those.
Okay. The first one I'll mention is that Matthias mentioned that good bread starts with sourdough. Yeah, but sourdough comes from yeast. So if you're making your own sourdough, it's a little bit of yeast, and the more yeast in your room, the better. So yeast is it's the basis for all great breads. So anyways, okay, questions. So Heather, do I just kind of scroll? Although I guess there's a question mark for any of the questions, right?
Official proper questions have got question marks on them, yes. Some people don't always put question mark, but I think mostly they.
Well, let me scroll through really quick and see what we got here. So, okay, so Jackie, why make a separate behavior folder when there's already one in the framework? All right, so good question. For the UI, so let's go back to our folder here. So what Jackie's talking about is if we go back to our app folder and we look at the behaviors folder, we can put behaviors in here and they get loaded up with the app. When the app loads, all those behaviors get loaded into memory. So what I do though, so these are behaviors that I have that kind of apply either to multiple controls throughout my application. That's usually what's going in the root behaviors folder. So Jackie's asking, well, why do you have this behaviors folder in the UI folder? Well, so here's an example of my article editor. So Screen Steps is, you can edit articles. And this is the article editor stack down here, okay? And then you see in the behaviors folder, I've got, I don't know how many, 16 different behaviors that I use that are a part of it. For my purposes, I like to keep all the scripts that are just related to that one window together in one place. And so when, if no one has to load up that window for that, no one ever opens that window during the session, it never gets loaded into memory. But plus, if I know that that's all the code that window is specific to that window. So that's why I do it. It's just easier to organize. Otherwise, I'd have hundreds of behaviors sitting in that main root folder. So that's why I do that. So next question is by Don. So Levure could support CI/CD. Do you have this integrated to build process tool like Jenkins? I have not. So I haven't done anything with that yet, Don. Really, you should be able to, there should be lots of things that you can tap into if someone writes the tools. I don't have any tools available for that yet. I haven't tested any of them. So what would be great, if that's something you're interested in and you want to play around with it and let us know what you find out, that'd be great. But that's not something that I could offer any input on at the moment. Clarence, so do you have to include all of the folders with the executable? No, only the folders, only folders that, the folders that the app YML file points to. So if the app YML file references a folder and says, this is a folder that the application needs, or if, and that could be either in like the UI or libraries area, or it could be in there's a copy file section. Those will all get copied over, but not everything that you have in your development folder has to be copied over, but only if it's referenced in the app.yml file. Okay, next, do you already have plans for an LCB version of Levure? So LiveCode Builder version of Levure, I mean for building widgets, not for including only. No, so I don't see Levure as a tool for building, as an environment for building widgets. To me, that's something that happens in the IDE. Now, Levure does have, like with screen steps, what I do is I want it to be able to open up, like let's say I'm on a computer somewhere and I need to test screen steps, and I need to want to download the source code and I need to run it, make sure, do some testing on it. I include all the source for all of my extensions in my repository, so that's the extension source. And Levure has some code that will go through and build all of your extensions for you. So if you're on a platform where you don't have your built extensions, I don't keep the built version of the extensions in the repo, but there's a Levure command that will go through and build all those files for you. Because I think, let's see, if you look in at the end of the screen steps file, there's an extension section, and that has all of the source code. It tells you where all the source code is, so that Levure can go through and build those if need be. Okay. So another question by Martin. Have you considered having a text version of UI stacks as Monty did in LCVS so changes can be tracked in version control? I have not, and I'll tell you why, Martin. So I used LCVS for a while, and LCVS came about before script-only stacks were around. But it also, what LCVS did was it tried to solve the problem for code and user interface. How do we get user interface stacks out of the binary format and into version control? The problem that I had with that is that one of my criteria was that I should never have to remember to run a plugin or anything like that before I want to commit my code into the repo. And I should never have to remember to run any code after I check things out of a repo. I need to be able to check in and check out and know that I can just get to work. And with LCVS, you had to import and export things. And I found that sometimes I'd get in and start working and I forgot to run the exporter, and it just kind of caused a headache. And so for me, the system has to reduce the likelihood of error or any problems as much as possible. So at this stage, I'm okay with using binary stacks for my user interface in my version control systems. I just break out all my user interfaces into single stacks. They all go in the UI folder. So multiple people could work on different aspects of the UI if they want. And there's some other tools that could be developed that could make that even more granular. But I at this point, unless there was a blessed format by LiveCode that was like a script-only stack, except for the UI, where the file that was saved was text-based, then I don't have plans to do anything like that. Okay, so Jackie said the framework knows how to do that. Unfortunately, Jackie, I don't know what that refers to. So if you could clarify that, what that means in your sentence, then I will say yes or no, or maybe. So Willie says, to include the necessary folders and files, does one need to write an installer? No, so what happens is when Levure packages up an app, So behavior folders. Okay, let me go back to Jackie's question here really quick. So Levure, it's not Levure that knows how to load the behaviors. So what she's talking about is if we go back to UI, the UI folder, article editor, she was saying Levure knows how to take care of all these files. No, so if you remember in the demo when we created the main window, when I showed you how to do that, remember that I used LiveCode 8.1.5, and when I created the behaviors, I used the tools palette, and there was that little tool and that automatically created the script only stack, automatically assigned that stack as the behavior, and then added a reference to that stack to the stack files property. That's the key, is that my article editor file, stack right here has every single one of these behaviors is listed in the stack files property of this article editor stack. And so what happens is if I open this article editor stack in the LiveCode engine, the engine looks at the stack files property, sees where all the behaviors are located, and it loads them all up. So as long as you use that the stack files property, in which the IDE, the LiveCode IDE as of 8.1.5 will do automatically for you, then you won't have any problems. And so I thought that was a nice solution to using behaviors and not having to worry about them loading up. Okay, so back to Willie's question. Is it to include necessary folders and files, does one need to write an installer? So no, the installer is only for distributing the app on a platform. So when we packaged up the application, so the part that Levure handles by default is this Mac OS and this Windows folder, and Linux if you want. Well, here, I'll show you over here. So let's take this bare bones example. This doesn't have any extra code that's being run when you package up an app. And so this is what gets copied into the Windows folder. Now it is up to you to write a Windows installer that installs those. If you go to GitHub, the Levure GitHub page, there is an issues tab. One of the issues is that we want to write a helper that, we want to write a helper that will automatically generate an INO setup file for you, so that if you're using the INO setup helper and you build an installer, that it's automatically generated and it's placed, in this output folder. So you just have to open the file on Windows and press compile, and your installer is built and ready to go. That shouldn't be terribly difficult to do. It's on the back burner until, at least on my back burner, until Levure, all the other parts of Levure are in place. That could be something that somebody tackled, though, by all means. And for Mac OS, so like on Mac OS, it just creates this app that will launch and run, but it's up to you to create the DMG file. Again, we can have a helper. I use drop DMG to do that, and so I actually have a script. Let's see, show you the script here under build files. In the app YAML file, you can specify that a stack be run after you build. So here's my file, and this contains a whole bunch of code. I can show you really quick. Where we are, app build files. So this script gets run every single time that I package up my Levure application, and there's some messages that get sent to it. And so I go through, I do some stuff for my auto updater. I run some commands for drop DMG to create a DMG file. And so you can write custom code that automates your packaging process, your app packaging process. Okay. All right. Dan has a question. How do you best import an existing project into Levure, especially if all the scripts are in binary files? So the first step, Dan, would be let's break out. It doesn't matter if they're in binary, because Levure will work with binary files just fine. But what I'd look at my project and I'd say, all right, where are my libraries? Let's pull all the libraries out and stick them in the libraries folder. Okay, and that's assuming that they're in your current app. Those libraries are always being loaded into the message path. Do I have front scripts that my app uses? Put them in the front scripts folder. And then I would go through and I would look at my UI stacks. And at first you could if you have just one big monolithic UI stack, create a single folder in the UI folder and dump it in there, and just it should still work. And then as you as you kind of get your grip, as you kind of figure out Levure, then you can, and I did this with screen steps. If I had a complicated stack, I would just plop the binary stack in there and that would get committed to source. And then later on, I would go back and I would pull the parts out to make them behaviors and kind of finish the process. But there's no reason you can't do it piecemeal and do it little by little. And Willie said, are using it? So Willie just was asking if are you using a specific tool for the installer? Yeah, and so I'm using DropDMG and I use INO setup. Like I said, I'd like to have helpers for both of those. There's no reason that we can't come up with helpers that would automate that process. So let's see. So Robert is asking me to explain the benefits of encrypting. Encrypting, it means that people, if I send my application to you and you're using it, you can't open up my scripts and read my code. So with screen steps, like my commercial applications, I don't want people reading my code. There's certain things in there that I don't want people to have access to. And so encryption hides, makes it so that people just can't open up the code in their text editor and see what your app's doing. So that's the benefit of encryption. Now you can't do that with the community version. So Levure, if you're building with the community version, if you're trying to package up an application in the community version of LiveCode, it will not password protect stacks. It won't try to. It won't encrypt them. But if you have community or business, if you have the business version, then you can. Or I think Indy or business, right? So let's see. Martin says, regarding Dan's question, if your app is GLX based, what are tips for transitioning to Levure? I'll probably have to create a document for that, Martin. So Screen Steps was obviously a GLX based app that I converted. I'm now actually going to be converting my other app, Clarify. So GLX application framework was the previous application framework I wrote that I used for years, and there's a few people that use it as well. We need to probably talk about that more offline. You'll find there's a lot of similar concepts. There's a lot of concepts from GLX that I brought over to Levure. So, but we could talk about those specifics offline. Just send me an email or post something to the mailing list, the GLX mailing list. Okay, Harry asked, does the framework create a single consolidated app for iOS? Yes. So it's Levure is using the built-in standalone builder for in LiveCode. Levure does not try to recreate anything that the LiveCode IDE already handles. So when you build an iOS app, Levure is going to put all the files together in a format that the standalone builder likes, and a normal iOS standalone will be built. The cost is $0. So it's an MIT license. Jim asked, what's the cost? There's no cost. You go to GitHub, all the code is available. We are very open to community contributions, even if it's just going through the wiki and asking questions and helping us clarify things, fixing typos. This is a community project. The hope is that, LiveCode has this community version, but it's really hard for the community to work on projects together. And one of my hopes is that Levure will help us as a community to work on apps. Now, I built it because I had a commercial need, but there's certain things like application frameworks that I feel have to be in place for every development tool. Doesn't mean everyone has to use it, but there should be a standard that people can go to it. They start using a tool. There's a standard framework that they can just jump in and start using. That people are, there's a lot of people behind, that there's a lot of documentation for, that there's a lot of code for. I think that's very healthy for the environment. So this is a community project, and the hope is that more people will contribute and help it grow. Okay. And so Robert says, so packaging does the encrypting for your app. That's correct. The encryption happens during the packaging stage. Levure will never package anything or never encrypt anything, any of your development files. What level? It's just whatever the LiveCode engine uses. So the LiveCode, you can set a password for a stack. So if you look up the password property in the dictionary, you can see whatever information is in the dictionary entry. That's what I know. as far as what level of encryption. Okay. Got some thank yous in here. You're welcome, people. It's my pleasure. I think LiveCode has a great community. It's a tool that, I fell in love with years ago, and, we just all kind of do our part to hopefully help it grow and blossom and get in the hands of more people. So let's see. And those are all the questions I see. If I have not answered your question and you asked one, then would you please write it again and put the little red question mark by it, and I'm happy to answer it. I'm also just happy to stop talking. So, whatever works.
I think we're just about there. That was fantastic, Trevor. Yes, really, really interesting. And I think there's going to be a lot of people rushing over to GitHub now to take a look at this tool. So yes, I think we may have reached the end of day one. What do we think, people? Are we there?
Golf claps.
I'm going to
Well, it's great, Heather. Well, we should all give a little shout out to Heather as well, because Heather is the behind the scenes person putting this all together, pulling her hair out, and just making sure that things go as smoothly as possible. And she does a fantastic job. So thank you very much, Heather, because this is a huge project. It's a big project just to be a single presenter. And I think of organizing everyone, it's phenomenal. So thanks.
It's been a great experience, and the presenters have all been fabulous. So it's great, yeah. And thank you all for turning up. I'm really pleased with how many people have turned up, and I know lots of other people are signed up to get the replays. So yeah. So let me see now. We are at the end of day one, but it's not the end of LiveCode Global. Don't go away with the idea that's all you get. So we will be coming back next month, July the 13th. Put it in your diary, where day two will take place. And we're going to be having, let me see, Eleanor will continue her beginner's course. Michael's going to carry on with his excellent database exposition. Richard Gaskin's going to be with us to do a community talk. And it's just going to be jam-packed with more great stuff. Yes, Roger, I will send t-shirts. T-shirts are coming. Okay, so I'm going to say goodbye.
Sign off. Yeah. Goodbye.
And thank you.
Everyone have a great day, night, whatever it is for you.
Yeah. Bye.